Hello guys, my name is Balakrishna Srivastav and welcome to Code with BK. So in this video, we write a Java code to left rotate a given linked list by k places. So before we begin, it is a request to please subscribe to my channel because out of 100 viewers, only 2 to 3 are subscribed. More than 95% of my audience is not subscribed, and a subscription is very important. So please do subscribe to my channel. And one more thing before we start is that I teach coding in Hindi as well on a separate Code with BK Hindi channel. I started this Code with BK channel back in 2018, and then I had request to teach in Hindi if possible. So I started this separate Code with BK Hindi channel. So if you people are comfortable with Hindi, it is a humble request if you guys can spare 5 minutes, check this channel out and let me know your views and thoughts about this in the comments. All right. So we have to rotate a given linked list by k places. This is the class node we are using. This has the integer data, integer n. You can have any kind of data. We have integers, and this is the reference to the next node. This is basically important for creating a link. Okay. So we have to complete this function that takes the head of the linked list to be rotated, left rotated by k places, and then we return the updated new head. Okay. So we are given, say, a list. Okay. 1, the next is 3, 12, 18, and 27. Okay. The next of the last node is null. Okay. We have to left rotate this k times. Okay. So I'm going to take 2 approaches to solve this problem. The first one is going to be brute force. Okay. The second one is going to be optimized. Okay. Brute force method is very straightforward. We find the code to left rotate once. Okay. If you write a function that is able to rotate a list left by one place, we call a function k times. Okay. So this will give us a list left rotated by k places. Okay. So rotating left once, it means this goes left, this goes left, this goes left, this goes left, and this goes left. Since one goes out of the boundary, it comes to the other side. So the list that you get by rotating left one is, this is the new head, 3, then next comes 12, 18, 27, and then 1 comes on the other side, so it becomes 1 and null. Okay, this is your list. From this you have to get this list. Okay, for left rotate once. Now how can we do this? Let me just write this original list again. The idea is to bring this one after the last node. Okay, so what can I do is, also I can have multiple cases. For example, if my head is null, so I simply return null. Okay, because if my list is empty, there is no rotation that I can do. Second, if my head dot next is null. Okay, this is my head. Head refers to the first node of the linked list. If my head dot next is null, it means I have only one single node in my linked list. It means any number of rotations is going to give me the same list. So I simply return head. Okay, and then comes the third case where I have to actually do this rotation, placing this one at the end of the last node. Rotate left. All right. So in this third case, okay, when we have greater than one node, or at least 2 nodes, okay, we need to bring this one at the end of the last node. So the first thing that we do is find last node. Okay, so we can take a current pointer, iterate till the last node. So this is my last node in a separate variable. Now the second thing I need to do is save this new head. So this new head, I will save it in a variable next, which is basically head.next. So I'll say save the new head. And I'm saving this next in a separate variable because this is my new head in the rotated list. Okay, and I will have to return this new head because I need to return the updated head. Next, what I do, I need to move this one at the end. So I disconnect one from the list. Okay, so this next is now null. So you say disconnect head from list. So you say basically head.next is null. Then what you do, you place head at the next of the last node. You say set head to next of last node. In terms of code, this is simply going to be last node dot next is equal to head. And finally, you return the new head. Okay, which is your next. So you save last node in a separate variable. You save next in a separate variable. You move this first head after the last node, and then you return the new head. Okay, so if I write a function, okay, let me write a separate function to rotate left rotate once. So this simply takes the head because this left rotates once. So left rotate the list once returns the head of the rotated list. Okay, all right, so I do these cases, head is null return null or head dot next equal to null return null. So if head equal to null or head dot next equal to null, I return null. Okay, then I follow the steps, find the last node. Okay, so I take node current is head and I will move this forward as long as current dot next is not equal to null. This is a very standard code to reach the last node. I say current is current dot next. Okay, I say node last node saving current in a saving last node in a separate variable. Okay, then I say save the new head, which is next of head, save the new head. So I'll say node next is head dot next. Then I disconnect head. So basically simply head dot next is null. Alright, then I say fourth is set head to next of last node. So I say set head to next of last node. So last node dot next is head, okay, and return the new head, return next. Okay, so what is happening is if you are given this list, okay, first step that you do is basically you have last node variable pointing here. Okay, then you do save the new head, which is next is pointing here. Then you do disconnect head from list. So this next is lost, so the next is now null. So I will remove this point, this link. Okay, head is here. Okay, you got the head here. Okay, then you say set head to next of last node. This dot next is head, head is this, so this dot next is basically this. Okay, then you return the new head. So when this new head is returned in the calling function, my next is the new head. So this list is basically now 3, 12, 18, 27 and then 1 and then null. Okay, 3, 12, 18, 27, 1 and null. So now we have 3, 12, 18, 27, 1 and null, which is supposed to be our rotated list. Okay, left rotate once. Okay, so let me just test this. So I have a function to print the list, I have a function to create the list. So this is basically variable number of arguments, variable number of integers I will provide. So the order in which I provide the integers, a linked list is created of that. Let me just show this to you. Node L1 is create linked list. I'll say same values 1, 3, 12, 18, 27. Okay, that's a print list L1 and message is L1. Okay, so 1, 3, 12, 18, 27 is something you'll get. Okay, so if I add a few more values in between, say 0, say 9, say 20. Okay, 1, 0, 3, 12, 18, 27, 9, 20. The same order. Okay, taking back our original case. Okay, I need to rotate this left one, so I simply say L1. Okay, my new head of the rotated list is going to be stored back into L1. I'll say left rotate once, pass L1 and I print L1 again. So you see 3, 12, 18, 27, 1, which is what we want. Okay, if I add a few more values 0 and 9, so 1 is the new head now. So 1 is the new head now. Okay, running the original set of values again. Okay, so when you have to rotate, left rotate k times, you simply call, okay, rotate once k times. So I say call left rotate once k times. For int I equal to 0, I less than k, I plus plus. Okay, you say head is left rotate head and then you finally return the updated head. Okay, so if I have this list, I'm just going to write the list values and not the entire linked list form. I'll not use the arrows, basically saying the list, the values are in this order. Okay, so left rotate once will give you 3, 12, 18, 27, 1. Left rotate twice will give you 12, 18, 27, 1, 3. Left rotate third time will give you 18 is the new head, 27, 1, 3, 12. Left rotate 4 times will give you 27, 1, 3, 12, 18. Left rotate 5 will give you the same list again, 1, 3, 12, 18, 27. Okay, left rotate 6 will be the same as left rotate 1, so 3, 12, 18, 27, 1. Okay, so if the length of the list is 5 and you have to do k rotations, so we do k equal to k percent length of the list. In this case it is 5. So if k is 6, okay, so we do k equal to 6% 5, which is 1. So that 6 and 1 will have the same rotation, because after length number of rotations you get the same original list. Okay, so for 7th rotation you have 12, 18, 27, 1, 3, right, which is same as for 2. So if k is 7, you do 7% 5, which is 2. So for k equal to 7 and k equal to 2, you have the same number of final list. Okay, same rotated list. So we do this before calling left rotate function k times, because we want k to be between 0 to len minus 1. Okay, alright. So I do k is equal to k percent length of the list. So I'm going to write a separate function to find the length of the list. Static int len node head. Length of the list is just iterating the entire list. So I can use this code and I say current is not equal to null. I do n plus plus, which is storing the length. Okay, and I say k percent len of head. Okay, and then perform k rotations. Okay, copying and commenting this out, left rotate k times. Okay, and let's take k equal to 2 for now. Okay, so for k equal to 2 we get 12, 18, 27, 1, 3. So we get 12, 18, 27, 1, 3. For k equal to 3 we get 18 as the new head. We get 18 as the new head. 18, 27, 1, 3, 12. 18, 27, 1, 3, 12. K equal to 4. Okay, we get 27, 1, 3, 12, 18. For k equal to 5 we get the original list. Okay, for k equal to 5, this is the original list. Okay, for k equal to 5. For k equal to 6 we get 1. Okay, alright. So this is left rotation k times of a linked list, and since this is on, okay, because we are iterating the entire length of the list, okay, this is going to be left rotate list k times, left rotates list k times, okay, returns the head of the rotated list, and this is nk, because the outer for loop is running k times, the inner code is calling left rotate, which is on. Okay, now we move on to our optimized version. Okay, where, so this one will take onk, this optimized version will take on. So we move on to our optimized version. Okay, I'll make this left rotate 1, make this left rotate 2. Okay, and this is on. Okay, return null. Okay, okay, so in the second case, in our optimized case, we just move nodes. Okay, now for example, we take the case for k equal to 3. My original list is 1. For k equal to 3 I should get this. Okay, so for k equal to 3 I should get 18 as my head. Okay, so from this list you have to get this list. How? K is 3, so you can see the first k nodes, which are 3 nodes, have moved after the last node. So if I cut the list from here, make the next of 12 the third node, okay, after the first 3 nodes as null, this is my head, original head, okay, of the original linked list. I place this head after this 27, so I will get this, because 27 next is going to be head, so it will be 18, 27, 1, 3, 12, and this will be my new head. Okay, very similar to what we did, but in this case we are just finding the new head after the first k nodes. Okay, because if k is equal to 2, okay, so the resulting list is going to be 12 is my head, 18. Okay, so for k equal to 2 I skip the first 2 nodes, disconnect this, set the next of 3 to null. Okay, this 12 is my new head, 12 is my new head, and I place this head after the last node. So last node's next is now this head. So 12, 18, 27, 1, 3. 12, 18, 27, 1, 3, and next of 3 is okay. So for some reason it got deleted. It happens at times, but that's okay. I mean, we have what we want. So for case k equal to 3, we want this list from this list. For k equal to 2, we want this list from this list. And if these are the given set of values, after first rotation we get this, after second rotation, after third, after fourth, after fifth, after sixth, and we saw we need to do k equal to k percent len of the list, okay, because first and sixth will be the same, 0 and fifth will be the same, second and seventh will be the same, okay. All right, we saw in this case that after the first three nodes we disconnect this, make this null, okay, this is my original head, okay, and 27 next becomes the head, so it is now, this is my new head. This is now 18, 27, then 1, 3, 12. Okay. Similar in this case, after the first two nodes, I find my new head. Okay. I disconnect this, set this to null. This is my original head. Okay. Which is set in the next of the last node. So it is 12, 18, 27. Then next becomes 1, then 3. 12, 18, 7, 1 and 3. And next of 3 is null. So putting this down in steps, first is find last node. Okay, because we will have to set the head to the next of last node. Then B is find new head, okay, which is after first k nodes. Okay, third is disconnect first k nodes. So if you skip the k nodes and you have your current pointer here, your new head is current dot next, and you set current dot next to null. That is how you disconnect the first k nodes. D, put head after next of last node. Okay, so you say last node, not next, is head. All right, and then finally return new head, which is your new head that you save. Okay, putting this into code. Okay, the first thing that we do is this. Okay, and then we do this check. Okay, all right. Also, if k is equal to 0, we need to return the same list, because k equal to 0 means no rotation, or if k equal to the length of the list or twice the length of the list, okay, that will be 0 rotations. Okay, so you find the last node, which you can take from here. Okay, then we skip the first k nodes. Okay, so we say current is head. Okay, for int I equal to 0, I less than k, I plus plus. Second step is find new head, right? Okay, we say current is current dot next, and your node new head is now next of current, so current dot next. Okay, all right, your current is here, my new head is this. Okay, then you say disconnect first k nodes. Okay, disconnect first k nodes. How you do that is set next of current to null, current dot next is null. Okay, I'm just going to show you this step by step in the same list. Just give me a moment. Okay, let me complete the code. Put a head after the next of the last node, place head after last node. So last node that we saved, its next is now our original head. Okay, and then finally we return the new head. So return the new head. So we say return. Okay, what we are doing this in this again, given for k equal to 3, I have this original list. Okay, I find the last node. Okay, current starts with head, goes till current is not equal to null, so my last node will come here. A very standard code. Okay, I have current equal to head again, and I equal to 0, I is less than k, I plus plus. Okay, this I will make 1 because current is starting from the very first node, so I is at the first node, and we have to go till k nodes. Okay, so I is 1, current is here at head. Okay, current is current dot next, current becomes current dot next. Okay, I is incremented, I becomes 2. Okay, 2 is less than k, I is less than k is the condition, so 1 was less than k, 2 is less than k, 2 is less than 3. Current is current dot next, so current comes now here. Okay, I is incremented, I becomes 3, I less than k is now false, so current is now here at the kth node, at the third node. Okay, then in our code we say new head is current dot next. This is our new head, currents next. Okay, so we save last node, we have current, we have new head. Okay, then we say current dot next is null. We are disconnecting the first k node, so we say this next is now null. Okay, so we have right now at this particular point 1 3 12 and null. Okay, and we also have 18 27 and null, where this is the last node, this is the new head. Okay, this is current and this is head. Okay, then you say last dot not next is head, last dot next is now head. So the list is now 18 27 1 3 12, which is what we want. 18 27 1 3 12 for k equal to 3. Okay, so you write this as, this is the same as 18 27 1 3 12 and null. Okay, your new head is at 18. Okay, your current is, your last node is still here. Okay, your head is still here, your current is at 12. These are the 4 pointers here. And finally new head is returned, so we return the new head. Okay, so now my list is 18 27 1 3 12 and null. Okay, testing this now. So left rotate 2, so this is left rotate 1. Okay, so left rotate 2, left rotate 2, so 3, the first case that we checked. Okay, 18 is my new head. For 1 it should just rotate once. Okay, for 2 12 should come. Okay, for 3 18 should be the head. For 4 27 should be the head. For 5 we should get the original list again. Oh, we are returning null, we need to return head, my bad. Okay, so 5 we return the original list. Okay, for 0 also you should get the original list. Okay, for 10 also you should get the original list, which is the twice the length. Let me add some values. 0 9 minus 3 4, rotating it by 4 times. So 1 0 3 4 9, so 12 is the new head. So 12 3 18 27 4. Okay, and then the remaining list. Okay, all right, and the runtime of this is on, because we are going maximum to the list. Okay, all right, let me check with a single list. Single node list should give you the same list. For an empty list, by 0, so I have, oh, %0 is not allowed. I need to take out this %0 is giving an error, so I need to take this condition out separately. Okay, if it is head is null or head dot next is null, I'll return head, and then I do this. Okay, this is better. Okay, now when I run this, this is okay. All right, so again with 1 2 3 4 5 values. Okay, rotate list once, I should get 2, then twice should give me 3 as the head, 4 should give me 5 as the head, 5 should give me the original list, 6 should give me 1 rotation, and okay, all right. So this was the solution to this problem, and I hope this was helpful. So if there is any doubt, there is a part you don't understand, please let me know in the comments. I always try to answer all your comments, and you can always let me know in the comments if there is a question you want to solve or if this concept you want to discuss. So please like this video, subscribe to my channel, and thank you for watching.